podcast. Everyone at journal page 29, fitting linear model to data. A line of best fit is a line that comes closest to all the points in the data set. Linear regression is the method for finding a line of best fit. The table shows the latitudes and average temperatures for several cities. Use your calculator to find an equation for a line of best fit. Round your values to the nearest hundredth. Solve the equation to find the temperature in Panama City. Round to the nearest whole number. Then identify and interpret the correlation coefficient. All right, so to find the equation, we're going to use our calculator. So we're going to always go to On, New Document, and we're going to add list and spreadsheets, X, Y, and then we're going to plug the table values in. All right, now you'll notice that 8.6 doesn't have a value, so we're going to delete that and not use that in our data, okay? So now we're going to define the equation. We're going to do Control Doc. We're going to go to number 5, Tab X, Tab Y, and then we're going to go to Menu, Analyze Graph, Regression, Show Linear MX plus B. All right, there's our equation. Remember, we're rounding to the hundredths, so that's 2 decimal places. So y equals negative 0.94. Now, the 6 rounds to 4 to a 5. X plus 71.4. 0.14, sorry. All right, so there's our equation. Now we're going to find the temperature when it's 8.6 degrees latitude. So to do that, we plug in 8.6 in for X because that's the X value. This is the X. This is the Y. Okay, so we plugged it in. So Y equals negative 0.95 parentheses 8.6 plus 71.14. And we can use our calculator to calculate that. So I'm going to press on, and I'm going to go to calculate. And then we're going to put that in. So negative 0.95. Oh, the negative symbol's right there. 0.95 parentheses 8.6. Click to the right. Plus 71.14. Now, they want us to round to whole number, so that's going to round to 63 degrees. All right. So y equals 63. All right. So the temperature in Panama City, Panama, should be around 63 degrees Fahrenheit. Now we need to find the R value. So we're going to go back to our calculator, and I'm going to press on, and I'm going to go to current. And I need to click over here to 1.1, and I'm going to go over to C1, and then we're going to go to Menu, Statistics, Stat Test, Linear Regression T-Test. X and Y. Press Enter twice, and we're going to go down to the R value. Not the R squared, but the R value. So R equals negative 0.997. And the reason why I wrote the third digit, because the 7 rounds a 9 up to 10, which rounds that 9 up to a 10, which rounds us up to -1. Okay? So the correlation coefficient is closest to -1, which indicates a strong correlation. All right, let's look at the next example. All right, example 2. The table shows latitudes and average temperatures for several cities. Use your calculator to find an equation for a line of best fit. So line of best fit. Round your values to the nearest hundreds, that's 2 decimal places. Solve this equation to find the temperature in Kuwait City. Kuwait round it to the nearest whole number, then interpret the correlation coefficient. All right, so to find the equation, we're going to again use our calculator. All right, we always want to go to on, new document. No, we're going to go to add list and spreadsheet. So then that's X, Y, and then 59.6. All right, now here's where probably you might realize 29.2 doesn't have a Y value, so we actually need to delete this and redo it and ignore 29.2. So we're going to start back at 24.3. All right, now, again, to find the equation, we're going to go to menu. Oh, wait, not menu, sorry. Control Doc number 5, Tab X, Tab Y, Menu, Analyze, Regression, Show Linear MX plus B. All right, and we're going to move the equation so we can see it. And remember, rounding to 2 decimal places. So equation is y equals -0.76x plus 69.81. All right, so we have our equation. Now we need to find the temperature Kuwait City. So we're going to plug in the x of 29.2 into the equation. So you have y equals -0.76 times 29.2 plus 69.81. All right. So I'm going to come over here. I'm going to press on, go to calculate, delete the previous problem, and then the negative's right here, -0.76, parentheses 29.2 plus 69.81. So y equals 47.618, which we're going to round to 2 decimal places. So that's, well, actually, I'm sorry, they want it to a whole number. So the 6 raises the 7 to 8, so y equals 48. So the temperature in Kuwait City should be around 48 degrees Fahrenheit. Now we need to find the R value, okay? So we're going to go back to our calculator, press on, go to current, and then go back to 1.1, go to C1, and then go to menu, statistics, stat test, linear regression t-test, x and y. Press enter twice and go down to when the R value is, all right, so R equals -0.98. All right, So R equals negative 0.98. The correlation coefficient R is negative, meaning the latitude and the temperature are inversely related. All right, go ahead and finish up example 2. All right, last example. The table shows latitude and average temperatures for several cities. Use your calculator to find an equation for a line of best fit. Round your values to the nearest hundredth. So line of best fit, nearest hundredth. Solve the equation to find the temperature in Jerusalem, Israel. Round to the nearest whole number. Then identify and interpret the correlation coefficient. All right, so to find the equation, we're going to use our calculator. So again, we're going to go to On, New Document, No, Add List and Spreadsheets, X and Y. All right, and then we're going to plug the values in. Now you'll see that 31.5 is the next value, but it doesn't have a value for y next to it. So we're going to ignore that point and go to the next one, 29.6, 18.3. All right, so to find the equation, we're going to go to Control Doc number 5, Tab X, Tab Y, Menu, Analyze, Regression, Show Linear mx plus b. And we're going to pull the equation over so we can see it. So your equation is y equals negative 0.87 x plus 85.19. All right. So now we need to find the temperature in Israel should be around. So we're going to use that equation, and we know x is 31.5. So we have y equals negative 0.87 times 31.5 plus 85.19. So let me go back to the calculator. So I'm going to press On, Calculate, delete the previous problem. So negative button's right here, 0.87, parentheses, 31.5, click to the right, plus 85.19. So y equals 57.785. So the 7 rounds the 7 up to 8, so we round it to a whole number of 58. So the temperature in Jerusalem, Israel should be around 58 degrees Fahrenheit. All right, now we need to find the R value. So again, we go back to the calculator. Okay, we're going to go to On and then go to Current. We need to go back to the 1.1. We're going to go back up to C1 and then go to Menu, Statistics, Stat Test, Linear Regression T-Test, X, Y, enter, and then we're going to go down to the R value. So R equals negative 0.99, which rounds to negative 1. So the correlation coefficient R is approximately negative 1, which indicates a very strong correlation. So the line of best fit is reliable for estimating temperature within the same range of latitudes. All right, go ahead and finish up the example and start working on your assignment, and have a wonderful Wildcat day.